In this video, I will walk you through several multiple choice questions from past AP Calculus exams pertaining to Unit 7, which is all about the 7 fundamental theorems of calculus. This is part 2, so if you really want to understand what's going on, you're going to want to watch part 1 first. I'll put a little pop-up link in the upper right-hand corner. Number 6 is a calculator active question, so we will use our graphing calculator as needed. A point moves in a straight line so that its distance at time t from a fixed point on the line is 8t minus 3t squared. What is the total distance covered by the point between t equals 1 and t equals 2? Here are some notes that you need to have memorized for this type of problem. The total distance traveled during the interval from a to b is equal to the integral from a to b of the absolute value of the velocity. Without the absolute value, you're talking about net distance or displacement, which is not the same thing as total distance. So what I need is a velocity function, but what I have is a position function. Of course, in order to get the velocity, I can take the derivative of the position. So that's going to be 8 minus 6t. So the total distance traveled during the interval from t equals 1 to t equals 2 will be the integral from 1 to 2 of the absolute value of this velocity function. I can type this into the calculator. So let's see, I need the integral from 1 to 2. So I hit Math 9, and we're going to do from 1 to 2. Then I need the absolute value. So hit the Math button, switch over to the Num menu, and absolute value is the first choice. So I have the absolute value, and it was 8 minus 6t. So I type 8 minus 6x dx. Kabam! And so this is the answer in decimal form. Now let's look over the options and see which one is a match. 5/3 is approximately 1.667, so the answer is C. Number 7. Let capital F of x be an antiderivative of natural log x to the third power divided by x. If capital F at 1 is equal to 0, then capital F at 9 is equal to what? When they say that capital F of x is an antiderivative of this function, it means that if I take the derivative of capital F, it should equal this function. Whenever they give me the value of a function at one point, and then they ask me to find the value at another point, I think I'm probably going to use the first fundamental theorem of calculus, where the end value is equal to the initial value plus the net change in value. The net change in value is the integral of the derivative. In other words, the first fundamental theorem of calculus tells me that capital F at b should equal capital F at a plus the integral from a to b of capital F prime. So in this case, capital F at 9, which is what I'm looking for, should equal capital F at 1 plus the integral from 1 to 9 of capital F prime, which we are given in the form of this function. We know that capital F at 1 is equal to 0, so we can go ahead and substitute that in. We also have the expression for capital F prime, so we can put that in. The entire right-hand side of the equation is something we can simply put in the calculator. I'm not going to put the 0, but we have the integral from 1 to 9, so we're going to hit Math 9, and so here goes the integral from 1 to 9. We have a fraction in here, so I'm going to hit alpha y equals enter, And then in the numerator, we have natural log x to the third power. So let's go ahead and put parentheses, natural log x, and all of that is to the third power. And then in the denominator, we just have x. Put a dx on that, and you've got a deal. Kabam! So 5.827 if you round up. So the answer is C. Number 20. Let f be the function given by f of x equals x to the third power minus 3x squared. What are all values of c that satisfy the conclusion of the mean value theorem of differential calculus on the open interval from 0 to 3? Notice this just says the mean value theorem, not the mean value theorem for integrals. So the mean value theorem says that f prime at c will equal f at 3 minus f at 0 divided by 3 minus 0 for some value of c. Let's calculate f at 3 off to the side. We have 3 to the third power, which is 27, minus 3 times 9, which is also 27. So guess what? 0. It's pretty easy to see that f at 0 is also going to be 0. So we have f prime at c is equal to 0 minus 0 over 3 minus 0, which of course equals 0. But what is f prime at c? Well, looking at x to the third power, the derivative will be 3x squared, but I'm going to put 3c squared. And then we have minus 3x squared, so that's going to become minus 6c. So this is f prime at c, which should equal 0. Let's solve this for c. I see a common factor of 3c, so let's factor that out. So I will pull out the 3c outside of the parentheses. That's going to leave behind c minus 2. Using the zero product property, we can set each of these equal to 0, and that's going to give us c is equal to 0 from the 3c equals 0, and c is equal to 2 from the c minus 2 equals 0. So these are the two answers that I see. Oh yeah, so one of these will be eliminated because we have the open interval from 0 to 3, meaning that 0 itself is not included in the interval. So that one's gone. Kabam! That just leaves c equals 2 only. So the answer is B. Number 22. If the position of a particle at time t is negative 5t squared, then the average velocity of a particle for the closed interval from 0 to 3 is which of these? To find the average velocity on the closed interval from 0 to 3, we will use the average value formula. I think of it as the integral divided by the interval. 3 minus 0 is 3, and dividing by 3 is the same as multiplying by 1/3. I'm going to write it this way just to save space. As we integrate negative 5t squared, I'm going to bring down the t and increase the exponent. So this will now be t to the third power. Then I divide by the new exponent. So I will have negative 5 divided by 3. Don't forget about the 1/3 that is still out in the front. I'm just going to bring that down. And we need to evaluate this from 0 to 3 using the limits of integration. 1/3 times negative 5/3 is negative 5/9. And I am going to find the value at 3 minus the value at 0. So I'm really just evaluating t to the third power. So this will be 3 to the third power minus 0 to the third power? Well, this is just going to be negative 5/9 times 3 to the third power, which is 27. 9 goes into 27 3 times. So we are left with negative 5 times 3, which is negative 15. This is the average velocity. The answer is C. Number 23. Let f be a twice differentiable function such that f at 1 is equal to 2 and f at 3 is equal to 7. Which of the following must be true for the function f on the closed interval from 1 to 3? Statement 1. The average rate of change of f is 5/2. This is just a formula. The average rate of change of f on the closed interval from 1 to 3 is f at 3 minus f at 1 divided by 3 minus 1. We are given that f at 3 is 7 and f at 1 is 2. So we have 7 minus 2 over 3 minus 1. That's 5/2. So that first statement is true. Now let's see if the average value of f is indeed 9/2. Here's the formula for the average value of f of x on the closed interval from 1 to 3. And I don't think we have any way of calculating the integral of f of x from 1 to 3. We're going to leave statement number 2 unchecked. Moving on to statement number 3, let's find out if the average value of f prime is 5/2. The average value of f prime on the closed interval from 1 to 3 is the integral of f prime from 1 to 3 divided by the interval 3 minus 1. 3 minus 1 is just 2, and dividing by 2 is the same thing as multiplying by 1/2. So I'm going to write it this way just to save space. When you integrate f prime, you get f. So we're going to have f of x. I'm going to just leave the 1/2 out there in the front as I evaluate using the limits of integration from 1 to 3. And remember, this means we need to find the value of f at 3 minus the value of f at 1. So we're going to get 1/2 times f at 3 minus f at 1. So that's 1/2. And then we know that f at 3 is 7. And we know that f at 1 is 2. 7 minus 2 is 5. So we have 1/2 times 5, which is 5/2. So the third statement checks out. That means that the answer is D. Statement 1 and 3 only are true. By the way, it's not a coincidence that the average rate of change of f is the same thing as the average value of f prime. That is always the case. This last problem is calculator active, so we will be using our graphing calculator as needed. Let f of x equal the integral from 0 to x squared of sine of t dt. At how many points in the closed interval from 0 to the square root of pi does the instantaneous rate of change of f equal the average rate of change of f on that interval? So it sounds like we need to find the instantaneous rate of change and the average rate of change and set them equal to each other. The instantaneous rate of change is a long way of saying derivative. So we need to find f prime. But how do we take the derivative of an integral defined function? Well, that's what the second fundamental theorem of calculus is all about. You find the value of the inner function at the upper limit of integration, and then you multiply by the derivative of that upper limit. And then you do minus the value of the inner function at the lower limit of integration times the derivative of the lower limit. So my inner function is sine of t. So I need to evaluate this at the upper limit of integration. So I'm going to put in the x squared. But then I'm going to multiply by the derivative of that upper limit. So I'm going to multiply by 2x. Then I'm going to subtract, and this time I'm going to evaluate sine at the lower limit of integration, which is 0. And then I multiply by the derivative of 0, which is 0. Multiplying by 0 wipes out the second term. So we just have f prime of x is equal to 2x times the sine of x squared. This is the instantaneous rate of change. Now let's find the average rate of change on the closed interval from 0 to the square root of pi. So the average rate of change of f of x will be f at the square root of pi minus f at 0 divided by the square root of pi minus 0. Let's come off to the side and figure out what f at the square root of pi is. So this is going to be the integral from 0 to the square root of pi squared of the sine of t dt. The square root of pi squared is just going to be pi. The antiderivative of sine t is negative cosine of t, but we need to evaluate from 0 to pi. So that means we need to find the value at pi minus the value at 0. The cosine of pi is negative 1, and the cosine of 0 is positive 1. So negative 1 minus 1 is negative 2. But then the opposite of negative 2 is positive 2. We will also need the value of f at 0, but that's very easy to come up with because that will be the integral from 0 to 0 of sine t dt. When the limits of integration are the same, there's no area between those 2 points, so this is going to automatically be 0. So getting back to the average rate of change on the closed interval from 0 to radical pi, we have f at pi is 2, and f at 0 is 0. So that's 2 minus 0 over the square root of pi minus 0. So those zeros aren't really doing much, are they? So we really just have 2 over radical pi. But the question is, for what values of x on the closed interval from 0 to radical pi will the instantaneous rate of change equal the average rate of change? We can solve this equation using the graphing calculator. Hit the y equals button. Let's put the instantaneous rate of change on y1 and the average rate of change on y2. So there's my instantaneous rate of change on y1. For the average rate of change, I want a little fraction, so I'm going to hit alpha y equals enter, and I want 2 over the square root of pi. So square root of pi. Ultimately, we want to graph these and see where they intersect. But first, let's adjust the window a bit. What was that interval again? 0 to the square root of pi. So let's let the x min be 0, and let's make x max be the square root of pi. I'll leave y min and y max at negative 10 and positive 10 for now. Go ahead and hit graph and let's see what we've got. Alright, so we seem to have an intersection point here and here. And you know what? I'm just remembering that they didn't actually ask us what these intersection points are. They just said how many. And there are 2. So the answer is C.